is a type of medicine that trains your body to fight any foreign agents.
Plants are helpful for the ecosystem.
It's an electronic device for storing and processing data.
The nervous system is all the collection of nerves in your body.
Yeast is a eukaryote.
Welcome to Spectacular Science, where it's all about science, with your host, Akshay. Hey listeners, welcome back to this episode of Spectacular Science. I'm your host, Akshay. Do you know what solar and lunar eclipses are? Well, that's what I've been wondering about too. And in this episode, we're going to take a deep dive into the science of solar and lunar eclipses, how they happen, and what the difference between those two are. So, first of all, wait. It's the middle of the day, so why is the sky getting dark? Well, it's a solar eclipse. A solar eclipse happens when, at just the right moment, the moon passes between the sun and the earth. Sometimes the moon only blocks part of the sun's light. This is called a partial solar eclipse. Other times, the moon blocks all of the sun's light. This is called a total solar eclipse. As the moon blocks the sun's light, it casts a shadow on part of the earth. Again, this only happens when the sun, moon, and the earth are in a perfect line. Partial solar eclipses don't actually mean that the moon, sun, and earth are in a perfect line, but in total solar eclipses, you need them to be in a perfect line. So, from left to right, here is the order. First comes the sun, then the moon, then the earth. So, what's in the middle? The moon, because the moon is casting a shadow on earth. Now, as that happens, the trail of the moon's shadow actually moves around because the earth rotates. This trail is called the path of totality. If you want to experience total darkness during an eclipse, you have to be in the path of totality. In that path, the moon completely blocks the sun's light for a few minutes. It gets so dark that it looks like nighttime during a full moon. If you don't know what's happening, it can be confusing. Animals can get confused too. But this total darkness can also be kind of cool for scientists who want to study the sun's atmosphere called the corona. The corona is very dim. It's usually hard to see because the sun is so much brighter. But when the moon blocks out the sun's light during an eclipse, all you can see is the light from the corona. Total solar eclipses happen over land where people can see them. They don't happen that often. But when they do happen, the moon gives scientists and the rest of us a glimpse at the corona's beautiful streams and ribbons. Say thanks to the moon for giving us this amazing experience. And you know what the best part of the solar eclipse is? It's so rare because the moon's orbit is actually tilted. If it wasn't tilted, that means that solar eclipses could happen almost every month. But that's not what happens. A solar eclipse can only happen about once or twice a year in different areas around Earth. Since the moon's orbit is very slightly tilted, that tilt actually makes solar eclipses and almost any eclipse rare because they don't line up all the time. They only line up at certain times that actually favor conditions for solar and even lunar eclipses. Solar eclipses are something that are really cool, and some of them are coming up in the US as well. And it's just really cool to think that all these solar eclipses are so rare and we get to see them a lot. And there are actually different types of solar eclipses. The one that we talked about just now is a totality eclipse, or a total solar eclipse. This happens when the moon and sun and the earth are completely in line. And then a partial solar eclipse happens when they're not always in line. They're just a little bit misalignment. But what you see during a partial solar eclipse is kind of like a black spot moving through the sun, but it doesn't actually cover it up. Last is annular solar eclipses. That happens when the moon is not at the right angle to cover up the entire sun, but it does cover up a little bit of the sun. And when that happens, you see a small ring called the Ring of Fire around the moon, which is amazing to see. But how is that little tiny moon able to block out that giant sun? Well, it's all because of perspective. From Earth, we see the moon as really big, and the moon and the sun are roughly the same size in our night sky or in our daytime sky. So, since the moon is 400 times further away from the sun, and the sun is 400 times bigger than the moon, they kind of align together, and they kind of look like the same size to us. It's kind of like if you held up your thumb in front of your face, you could block out almost anything, like a person walking down the street outside of your window. You could just block them using your tiny finger, but really, it's just how you see it. And that's kind of how the moon and the sun are able to do that for us to see the total solar eclipse. Now, let's move on to lunar eclipses. Lunar eclipses are when Earth's shadow is cast on the moon. That's kind of the reverse of a solar eclipse, but we still see the moon in the night sky, even though the shadow is cast. So here's the order from left to right. First, the sun is right there, and it's emitting lots and lots of light that is able to reflect off of the planet or the moon. Next, in the middle is the Earth. And then on the right side is the moon. So this is when Earth's shadow covers up the moon. And it's kind of like a solar eclipse on the moon. It's more like an Earth eclipse, because if you were looking at this from the moon, you would see Earth and you wouldn't see the sun. It's kind of like a backwards solar eclipse. So when the Earth casts a shadow on the moon, what happens is that the moon appears to change colors. Wait, how does that happen? Well, during a lunar eclipse, certain colors are refracted through Earth's atmosphere. Again, the atmosphere is a blanket of gases on top of Earth. And that blanket of gases actually reflects or refracts light. And when that happens, you see things as different colors. So when the moon appears to be red, which is called the blood moon, that means that more red light is being reflected from the moon. And that shadow can cause some spectacular events. And it's really cool to just see the moon change colors. It kind of goes through all of its moon phases and then it turns into this different color, which is amazing to see. In fact, there's a total lunar eclipse coming up on May 15th here in the US. Isn't that amazing? Lunar eclipses happen a little more often than solar eclipses, but since the moon is again on a tilt a little bit in its orbit, they are still kind of rare. But you won't see people get excited for a lunar eclipse. But it's still amazing to see these lunar eclipses and these solar eclipses in person. If you see a lunar or solar eclipse in person, send us an email at podcast@spectacularsci.com. We'd love to see pictures of you watching the lunar or solar eclipse. Now, I've got to get ready to watch that lunar eclipse coming up. It sounds really, really, really cool. Well, before I go to get ready, what did we learn today? We learned that solar eclipses are when the moon moves in front of the view from the Earth and the sun. The moon kind of blocks the sun's view from Earth, and that causes it to be like nighttime. There are total solar eclipses when the moon covers up all the sun, annular solar eclipses when the moon only covers up a bit of the sun, but you can still see the ring outside of it, which is called the Ring of Fire, and partial solar eclipses, which is when the moon doesn't really cover up the entire sun, but still passes through our view. So it's kind of like a little black spot moving through the sun, but doesn't really block it out. Lunar eclipses are when Earth's shadow is cast on the moon. When this happens, it actually causes the moon to kind of change color, but it really doesn't change color, it just appears to change color from our perspective on Earth. Thank you so much for listening to this episode of Spectacular Science. Spectacular Science is produced and hosted by me, Akshay. Our theme song is by Charan Ramachandran. Special thanks to Varun Ramachandran. Please visit my website, spectacularsci.com, to find interactive activities, articles, blog posts, and so much more. That's spectacularsci.com. Please follow the Spectacular Science membership, where you can get bonus episodes, activities, and the fact of the day, a fun science fact every single day. Sign up at spectacularsci.com/membership. That's spectacularsci.com/membership. Please contact me. Email me at podcast@spectacularsci.com or head to spectacularsci.com/contact to find a contact form where you can send me questions, comments, and episode suggestions. I love hearing from you, and it makes my day whenever I receive a message. Please subscribe or follow Spectacular Science on Apple Podcasts, Google Podcasts, Spotify, or Amazon Music. By following, you get all of the episodes automatically and get notified when new episodes are available. To learn more on how to subscribe, visit spectacularsci.com/subscribe or click on the link in the show notes below. Also in the show notes, you can find episode descriptions and activities and articles that go along with this episode. Go to the episode description. Thank you so much for listening, and we'll see you on the next episode of Spectacular Science next Tuesday. Bye!